Hello, students. I hope everybody is good. In the last session, we discussed about the list. We discussed about the loops. We discussed about the tuples and strings. In today's session, we'll learn about the dictionary sets and how we can create a function inside a Python. So let's get started. We'll create our notebook now. We'll name this as day 3. Okay. So we'll start with the sets in Python. Basically, a set in Python is an unordered collection of data type that is iterable and has no duplicate elements. Remember, a set does not have any repetition of the values. Sets are mutable. That means you can add or remove elements after the set has been created. We'll write here this about the sets. So a set is an unordered collection data type that is iterable. Also, sets are mutable. That means you can create or delete the elements after once the set is created. Also, the set are represented like sets values are enclosed inside curly braces. As in case of tuple, it is enclosed inside round braces. In case of a list, it was enclosed inside the square brackets. Similarly, in case of set, it is enclosed inside a curly braces. Let's see how we can create a set inside a Python. We say we have a set name var, and we have some values. Let's say we have hello. Let's say we have Python. Then let's see if we have world. Okay. And let's see if we print type var. So basically here the type function uh, result in the the uh, type of variable. The var is of. So it's stating that it belongs to class set. Hence, var is a set here. Now let's see how we can typecast a list into a set. Suppose if we have a set name my set equals to, let's say we have a list here maybe of catching the character, maybe the similar one, this. uh, hello Python world. Okay, so let's say this is our list, which is now being converted to a set, and we write print my set. Let's see, does this print the set or not? Yeah, so now the list hello Python and world is now being converted to a set. Also remember that a set in Python is an unordered data type, which means we cannot know in which order the elements of the set are stored. Let's write this since it's important. Sets in Python are unordered data type, which means we cannot know, not know in which order the elements are stored. Now let's see. Also, as I told you earlier, that a Python cannot have duplicate values. Now let's see. We have, suppose we have a set, my set. Suppose if we have the set, we want to change the second element. Okay, so let's see how we can do it, or we want to change the first element. Like how you can change any element in a set. Let's see whether it is changing or not. Let's see that. Let's say we want to do for liquid. Okay, so say that we cannot change the element, cannot change the value of a set. Also, like we cannot assign or change a value once the set is created. We can only add or delete the items. Remember that sets allow modifications after it once it's created, but you cannot change a value. You can either add a value or you can either delete a value. Now we'll see the how Python sets store different elements of different data types. That is basically the heterogeneous nature of a sets in Python. Okay, so we left here where we created a new set such as we named it as my set, and we had three values: hello, Python, and world inside it. Now we looked whether we can add or change an element inside a set or not. Then we had another we tried like doing it. And we got to know that the Python does not support this. In sets you can only add an element or you can delete an element, you cannot change an element. Then we looked on to the Then we looked on to the heterogeneous nature of sets in a Python, where we got to know that the set has supports multiple values with multiple data types. We tried doing it. We took a set which contains the string elements, which contain the bool value, which also contains the float and the integer part. Okay, so then we looked on to the methods which are supported in sets. Number one is how we can add an element. Like we defined a set, suppose my set, and then we print it. Then we add an element work. Then we again print the set so that we could know that whether the changes have been made or not. Then if we have made any changes, then we can print it again. Okay, so these are the two sets. One is people and the other is states. And if we want to perform the union operation on this, let's see how we can do it. Union operation is basically the merging of two sets. So let's say if you want to perform the union operation and you want to save it somewhere else, let's say if you want to have, we have an another say named citizen. If we write people dot union, we write the other set, and if you print this citizen, let's see what does this gives. Okay, so since we can see that the people and the two states and the states have been merged, and the uh, values have been added in a new set known as citizen. Now we'll see how we can do it using the operator as well. Let's see if we do it like this. We write, let's say if we have a new set, suppose my set. Let's see if we define it as people. If we want to combine any two sets, we'll simply write this and we'll write sets away. Now we'll print both of this, my set and citizen. Let's see if we get the same output or not. Okay, so let's print this. Okay, yes. So the both of these statements perform the same operation, and hence we can say that either we can use the union function or the operator to perform the union operation on the Python sets. Now we'll see how we can perform the intersection operator operation. Okay, so the intersection operator is basically done through the intersection function or the AND operator. In this way, the common elements are selected. So let's see, we'll define a new set. We have a my set 1 as A, B, C, let's say. And if we have a new set, suppose my set 2 as is equal to A, comma, D, call it 4. Okay. And if you want to perform the intersection operation, let's say we have a new set, my set 3, which is equal to my set 1 dot intersection and we'll write here my set 2. Okay, now if you print this, okay, since we can see that in both of the sets we only have A as the common element, and hence this is printed. Let's see if we can do this using the AND operator or not. Yeah. And if you print the, let's see, okay, yeah, so the same things have been printed, and we can see that intersection operation basically performs that if there are any common elements between any two sets, then those elements will only be printed. Now we'll find the differences of sets. Let's see how we can do it. This time we'll try taking the values also. Let's see if we create any set. Let's see if we have. Let's see if we have a set equals to 0 comma 1 comma 2 comma 3 comma 4. Let's see if we have this set, and if we have, let's name this as set 1. Okay, then if we have a new set 2 as, sorry, yes, if we have a set, suppose 3 4 5 6 7 8. Okay, let's see if we have this. And if we want to perform a difference operator, we'll basically use the difference function here, and we'll store it in the set 3. Let's set this. Okay, set 1 dot difference set 2. Okay, and if we print the set 3 here, okay, okay, so from the first set, the elements of the second set are removed, and the remaining elements are being printed. Let's see if we change here. We write set 4 equals to set 2 dot difference set 1. Okay, if we print this set 4, okay, so here we can see that the uh, elements of set 1 are removed from the set 2, and the remaining elements are printed. Also remember that the set is a basically stores the values in a very unordered way, like the way you have stored may not be printed in the same way, so never mind that. Last operation we are going to perform is how we can clear a set. Okay, like how we can clear the elements inside the set. Okay, so we'll use the clear method to empty the whole set. Okay, let's see if we have a set 1. Okay, so if we have this set which has the value from 1 to 6, and if we want to clear it, let's first print this. If we say this initial set print set 1. Okay, and then if we write set 1 dot clear, then it must be empty. The set should become empty. And if we write print set 1, let's see what does this get. Okay, so here initially the set 1 is containing the values 1 2 3 4 5 and 6, and initially, and then when we use the clear function to empty the set does not contain any value. So this is how we can perform the union operation, intersection operation, difference operator, and the how we can empty a set. Also remember the union operation on the Python sets perform that all the elements of the set 1 and the set 2 will be merged. In case of intersection, the elements which are found common between two sets are only printed. In case of a difference, the order matters here, and the set which is written before is taken into account, and the second elements of state are being compared. Supposingly here, the if we write set 1 dot difference set 2, then the elements of set 2 from set 1 will be removed and the rest of the elements of the set 1 will be printed. Similarly, if you write set 2 dot difference set 1, then all the elements of set 1 from set 2 will be removed and the remaining elements will be printed. Clear is basically used to empty any of the set. Whatever values it is carrying, it will be removed, and a new and a fresh empty set will be created. Let's see how we can convert a set to a tuple. Let's see how we can convert a set to a tuple. We have a set name set1, which has the values. It's a, b, then we have, let's say, c. We have another element, let's add d. We have the last element as e here. Okay. Now if you want to couple a set to a if you want to convert a set to a tuple, what we'll do? We'll first of all simply print the type of s, like the type of a variable we have declared here. We know it already that it's a set since, but still we'll print for a better clarity that whether a set is converted to a tuple or not. Let's say type s. Okay. Sorry, it's not s, it's set1. Yeah. Okay. Here now we will use a tuple method. This method converts set to a tuple. Let's see if we want to name a tuple as tuple1, and we'll write here tuple set1. So this argument is basically going to be a set. If we print the type of tuple2, okay, let's run this. Okay, sorry, it's tuple1. Okay, so initially we know that the set1 was set and hence it belongs to a class of set. Secondly, when we converted set1 to a tuple using tuple method, we got to know that the it has been converted and it belongs to a class of tuple. So in this way, you can convert a set to a tuple. Now let's see how you can convert a set to a list. Okay. Suppose if you take a set, let's say set1 equals to 1, 2, 3, 4, 5. Okay, so we take this a very simple set, and if we want to convert it to a list, let's say we are converted as lst1, name the list as lst1, then we'll use the list function here and we'll put the parameter as the set name, which is set1. Okay, so here we'll print the type of set1. Okay, now we'll write here print type list. Okay, so since we know that set1 belongs to a class of set, and once it's been converted to a list using list function, then it has been converted to a class of list. Okay, now we'll see how you can convert a set to a string. This is very important, and we'll look how we can conversion of a set to a string. Okay, suppose if we have a set, let's say S, A, then we have B, let's say F, C, and D. Okay, so if we have a set, suppose let's say this. Now if we want to, let's say we want to print, let's say print as just to see the contents on the screen. Okay, now just to convert it into a string, you'll write, say S is equal to, let's say keep it as S is equal to strs, and let's say print S. So what's the problem here? It does not print this. Okay, there's some problem. I guess it's not printed. Let's name this as different. Let's say star one. Still, it's not giving. STRS. Okay, I think could be a problem. We'll see this problem in the next session. We'll discuss why this. We'll see this topic, that how we can convert a set to a string. Probably this was the only thing how we can convert a set to a string, but still we'll look into in the better way. So this was all about the set. Since we know that a set is an unordered collection of data type that is iterable and has no duplicate values. Also remember in the yesterday's session, when we want to remove the duplicate values from the tuple, we use the function set there. Then we found the type of a set, and we got to know that it belongs to a class of set. Then we see how we can add an element or delete an element inside the set. Also we got to know that we cannot change a value inside the set. Set contains the different multiple values of multiple data types. We saw different methods of adding an element inside a set. We also saw how we can perform the union operation on the set, how we can perform the intersection operation on sets, how we can perform the difference operation on sets, and how we can clear the set. Also, we got to know how we can convert a set to a tuple, how we can convert a set to a list, how we can convert a set to a string. Since there's a problem in some logical or maybe a programmable error, we'll see it in the next session how we can do it. Now we will learn about dictionaries. Okay. Dictionaries in Python. So basically, from the word dictionary, we understand that a word has a meaning. Similarly, in case of Python, a Python dictionary is a data structure that stores the value in key and value pairs. Like a value in a dictionary can be of any data type and can be duplicated, whereas the key can't be repeated and must be immutable. Also, a Python dictionary is a data structure that has stores the value in the key value pairs. Like it stores the value in the form of like each element will have a key and a value. Also, a value can be duplicated and can be of any data type, but the key cannot be repeated or cannot be have duplicate values and must be immutable. Immutable means it cannot be changed also. So we'll write this here. We have the multi-line comments. So multi-line comments basically starts from 3 upper quotes. Okay. dictionary stores the data in the form of key value pairs. So dictionary in Python stores the data in the form of key value pairs. Also remember that the values can be duplicated and can be of any data type, whereas the key is immutable and cannot be repeated. Okay, so let's start how we can create a dictionary. Let's say if we have given name to a dictionary as D here. Okay, so if we have a key, suppose we have first is always a key and then its value. Let's say if we have it as Python. Okay, if you have second element which has the key 2 and has the value as, let's say, hello. So this is just a basic way of how you can create a dictionary which has two elements inside it. Let's say if we print D, we print type of D. Okay, let's run this. Okay, so we got to know that a dictionary has been printed and it belongs to a class of dictionary. Okay, a dictionary can be created by placing a sequence of elements within curly braces separated by commas. Okay, now we will see how we can create a dictionary using dictionary constructor. First way is this, how you can create a dictionary. Let's see how you can create a dictionary using the dictionary constructor. Okay, so for that let's say we rename our dictionary as D1. Then we'll write this keyword here. Now let's suppose A equals to, let's say if we do it as let's say Python. And we'll write 2 is equal to, let's say, hello. Okay. This is the same example we took it in the first one. Let's say if we print D1 and if we print type of D1. Okay. Okay, so in this way we can also create a dictionary. Since I stays given an error expression cannot contain assignments, perhaps you mean this. Okay, so this is maybe probably okay. So there is some error. We'll see this how we can create a dictionary using the constructor. So this basically this way is the most convenient way to create a dictionary in which we can create a dictionary by placing a sequence of elements within the curly braces and then separated by commas. Let's see how we can access the elements. Okay, so we should know that Python dictionary are order. Okay, so the way in which you will like give the values, the way it will only be stored inside it. Dictionary keys are case sensitive. The same name but different cases of key will be treated distinctly, meaning differently. Keys must be immutable. That means you cannot. The keys can be strings, numbers, or tuples, but not list. Keys must be unique. Duplicate keys are not allowed, and any duplicate key will override the previous value. Also, we can access a value from a dictionary by using the key within square brackets or get method. Let's see how we can access the value from a dictionary. Let's say if we have a dictionary, let's say D. One is Python. Okay, and let's say if we have three. Okay. Now, if you want to access, let's say if you want to access a a, a value which is at which got the key as one, then we'll write it print d. Then we'll use here the key uh, to know the value. So at the key which has the value 1 has got the value Python. Similarly, if we go for 2, if we go for 3, it should print the values correspondingly. Okay, so the first one, the first the key 1 has got the value Python, the key 2 has got the value hello, the key 3 has got the value work, and same it has been printed also here. Now we'll see how we can add an element inside a dictionary. But basically adding an element inside a dictionary means adding a key value pair inside it. Okay, so let's say if we have a dictionary as okay, so and then if we have another key value pair, let's say this network. Okay, now we wish to add the element, and let's say D4, we write as world, let's say. Okay, and if we print this, let's suppose. So a new key value pair has been added, which is got the key 4 and the value as world. Supposingly, if you want to update an element inside the dictionary, we when we were studying about the sets, we got to know that we cannot change a value inside a set. Either we can add an element or we can delete an element. Here, in case of dictionary, we can change an element also. Let's see how we can do it. If we have a take an element inside a dictionary. Okay. Let's see if we have our dictionary as So the same dictionary we'll use here. Then if we have this third key value pair as spark. Okay, let's see this. Okay. So if you want to update an element, let's see if you want to update the value which has got the key as 1. To write d1 is equal to Python 3, let's say we'll do it. Okay, and then we'll print d. So here we can see that the element, the value of a key value pair has been changed, who's got the index as or key value as 1. It's now changed to Python 3. Now we'll see how you can remove the items from a dictionary. Okay. So to remove an elements, to remove the items from a dictionary, we actually got the 4 methods. First one is del keyword. Second we have the pop method. Third we have clear method. Fourth we have pop item method. Okay. Let's see how we can do it. The first one is if you want to if you want to remove the element using del keyword, how we can do it. Suppose if we have the same dictionary, if we have the set and we want to delete a key value pair which has got the index 3, then we'll write d. We'll simply write it 3. Okay, and then we'll print d to see whether the changes have been made or not. Okay, so the third index key value pair has been deleted. Now let's see how we can use the pop function. So if we have a set D which has 3 key value pairs, and if we want to delete the uh, key value pair which has got the key as 1, then we'll write, let's see, we just want to store that value as val, and we'll write d dot pop, and here we'll pass the index, let's say it's 1. Okay, so the Python key value pair has been deleted. And now if we use how we can use the clear function. Remember, the clear function will not delete a single element key value pair, but it will remove all the elements. Let's see if we have the same dictionary, and if we write d dot clear. Okay, we'll just print this one to see whether do we have do we have the changes which were needed or not. So okay, so the d is now complete empty and does not contain any key value pair. Now we will see how we can use the pop item function. So basically, to use the pop item function, let's see if we have variable, let's say key value. Okay. So using pop item, it removes and returns the last key value pair. Remember, the pop item will remove and return the last key value pair. Let's say if we have key comma value as d dot pop item, and if we see this, what does this gives to us? Okay, since this was empty, wait. Okay, okay. So in this way, we can delete an key value pair from the dictionary using del keyword, using pop item. The clear will empty all the elements inside the dictionary. Now we'll see how we can iterate through a dictionary. Let's see if we have a dictionary this. Um, let's see for will root. Basically, we'll write a comment here and we'll write will how iterating through dictionary. Okay, so yeah, we'll use basically we'll iterate over keys here. Let's see if we run a loop here for key in D print key. Then it will print all the keys. Okay, let's see. So the keys have been printed, which are 1, 2, and 3. Now, if you want to iterate over the values, or values in, remember, to get the values from a dictionary, we use d dot values, where d is the name of a dictionary. Okay. Now, if we print these values, okay, let's see what does this do. Okay, so firstly, it has given us the value of all keys. Secondly, the second part of the code, it has given the value. It has given the all values of the keys. Okay. And now we'll see whether there. Now we'll see the membership condition, whether a particular key value pair belongs to a dictionary or not. Let's say if you have a dictionary D equals to just got the value as, let's say, 1. Just got the value, let's say, 2. Let's see if this is a dictionary for us which has got the keys as A, B, and C, and the values correspondingly as 1, 2, and 3. Let's say if we have a variable, let's say key, okay, which holds the value, let's say B, okay, then we'll write a print statement. We'll see key in D, okay, So membership condition will always result in the form of either true or false. Like if there is a value inside a dictionary, it will result in true. If it is not there, it will result in false. Let's see. Okay, so the B is there inside a key. Let's see if we have a key equal to D. Let's say, and from this dictionary we can see that there is no such key which has got the value D. Okay, so let's see print. If you print this, like key D. Okay, it should result in false. Yeah. So there is no such key which has the value as D. Now we'll see how we can get the value of a, how we can know the length of a dictionary or how many key value pairs are inside a dictionary. Let's say if you have a dictionary D equal to, say the previous one only. Yeah. So we got this dictionary. Let's see how we can find the length. To find the length, we'll use the length function as discussed earlier. Okay, so it is results in 3. That means it has got the 3 key value pairs. So okay, now we'll see how we can uh, find the sum of all items in a dictionary. Let's write a comment here. Find the sum of all items in a dictionary. Okay, let's see if we have a dictionary. Let's say the okay, which has the value. Let's say key as A, which has got the value as 100. Another key which has got the value as B and has the value as 200. Let's say we have got the third key value pair which has got the key as C and the value is 300. Okay, now if you print, let's see if we got tell it as sum. Okay, if you use return sum, here the s of a sum should be capital and should have, okay, let's see what does this returns. Okay, okay, so there's probably might be an error. We do not could not have any supported library imported over, but this is basically a way how you can sum of all items in a dictionary. Okay, so this was all about the dictionary where we understood how we can create a dictionary, how we can access the elements using the keys, how we can add an element inside a dictionary, how we can update an element inside a dictionary, how we can remove it. We got the 4 methods there: a delete method, a pop function, a clear function, and a pop item function. Then we got to know how you can iterate through a dictionary using either you can use it through keys or you can also use it through values. For the values, we got the function as d dot values to get all the values of a dictionary. Then we thought that a particular key is there inside a dictionary or not, and it results in either true or false. Then we got to know how we can see the length or the number of key value pairs that are inside a dictionary. Then we've got to know how we can find the sum of all items in a dictionary. It's got some error. Basically, there's something not like defined or imported earlier. but this is just the basic way of how you can have a sum of all items in a dictionary. Now we will see the functions in Python. Okay, so uh, functions in Python is basically a block of statements that return the specific task. Okay, so function that are defined in Python are just a block of statements that return a specific task. The basic idea behind a Python function is to put some commonly or repeatedly done tasks together and make a function. So that instead of writing the code same times again and again with different inputs, we can do this by just calling the function again. So the basic idea for a function is that it is a block of code or block of statements that is being written for a specific task, and it has been done just to minimize the like it should minimize the rewrite of code by just because you just have to change some of the input values. Otherwise, the function and the motto of the problem is same. Then we define a function for it, and we can invoke the function anytime inside of a program to use it. Some of the benefits of the functions are it increase code readability. Like it like to perform a particular task, if you write a code a number of times, it becomes a bit boring and not like interested to learn about. So it is better to like call a function which has the like meaning and the interpretation already defined above. Also, the second benefit of using the function is that it increases code reusability. Like you can use the specific line of codes or statements anytime, anywhere in your code. So basically, the benefits of using functions is that it increases code readability and it increases code reusability also. So in Python, basically there are two types of functions. Number one is built-in library functions, and the second one is user-defined function. Built-in library functions, these are standard functions in Python that are available to use. User-defined functions are the functions that we create ourselves for our problems. So we'll write some of the basic things about function here. The function, okay, we need to have the comments. We'll do some multi-line comments here. Okay, function is a block of statements that returns the specific task. Okay. Some of the benefits of the code are benefits of functions. There are two basic functions. Number one is it increases code reusability. Okay, so these are some of the basic like functions benefits of the functions. In Python, they have basically have two types of functions. Number one is built-in functions. Second is user-defined function. Okay. Built-in functions are basically the functions that are already defined in Python. and you can use it anytime, anywhere in your code. Whereas the user-defined functions are the functions that you create on your based on your own requirement. Let's see how you can create a function inside Python. Okay, so we can create a function inside a Python using def keyword. A simple like you can say syntax to do it is given like as, let's say we'll write a def keyword here, then we'll write the name of function, let's say if it's fun. Then we'll have these parentheses for the parameters if there is any parameter required for the function to execute its task. And we'll have colon here, and then we'll have this. Okay. Suppose if we write print hello, you're inside a function. So this was just a basic example of how you can create a function inside a Python. Let's see how you can call a function inside. Okay. Calling a function inside a Python. Okay. Okay, so after creating, once your function is created, you can call it using like by the name of the function followed by parentheses containing the parameters. Like you can simply call the above function, which is fun, as fun, and then parentheses this. Now the function will call and will execute the task, that is, it will print that hello, you are inside a function. Okay, this is, suppose if there is a function which requires any parameter to execute its task, then when you call a function, you need to have the parameters defined inside these parentheses once you call this. Now let's see a simple example of how you can do it. Okay, if we write def, let's say def, we write this function from, okay, left this colon mark, like print hello are inside a function. Okay, suppose this is your function defined now. How you can call it? Let's say we use this. Okay. Okay. So in this way, you can define a function using def keyword followed by a name of the function with the parenthesis. Inside a parenthesis, you can give the parameters as per the requirement, and then the block of code which needs to execute a particular task. Then for calling of a function, you simply have to give the name of the function followed by the parenthesis. If parameters are needed, please like give the parameters inside the parenthesis. Now let's see a simple example of how you can add two numbers using function. Let's say we have, let's see, function to add two numbers. Okay. Let's see, we have def, we have the function name as add. We'll add, let's say we have two numbers. So let's say we have this int basically here defines that your num1 and your num2 are integer values, and it will only accept, like, it will only have the num1 and num2 as integers. We are, let's see, num3 is equal to num1 plus num2. And let's say we write, we return num3. Okay. Suppose if you want to call this, we have num1 comma num2 is equal to 5 comma 15, let's say. Okay, let's say answer is equal to add num1 comma num2. Okay, and we write print answer. Okay, so in this block of code we have a function named add, which basically has two parameters, num1 and num2, both defined as the data types as integer. Then this block of code is basically we giving a new variable name as num3, which is going to add the values of num1 and num2 which are there inside this function, and then it is going to return num3. Now this main block of code is that we have given two values to num1 and num2. Num1 will have the value 5 and num2 will have the value 15. Then this answer variable will hold the result of this add function and will print this. Let's see what this is going. Okay, so it's saying that 515 plus 5 is 20 and it's being printed. Let's see Python function arguments. So the arguments are the values that are passed inside the parenthesis of the function. What are arguments? Arguments is, in this case, num1 and num2 are arguments. Arguments are basically the values that are passed inside the parenthesis of a function. A function can have any number of arguments separated by commas. So basically, like an argument are the values that are passed inside the parenthesis of a function, uh, and a function can have any number of arguments that are separated by commas. Now we'll see a new program that will basically see whether a number is even or odd. Now we'll see whether the number is even or odd. We'll do this using a function. Let's say we will define a function. First we'll use the def keyword. Then we'll have let's say a function name as even odd, and then we'll have a value, let's say x inside it. Okay. Now we'll define a condition if this value of x, which is the argument of a function, if it is divisible by 2. Let's see. Then for divisibility, I told you in the first session that we use the percentage sign. If x percentage 2 is equal to 0, okay, then print, then x is even. Okay, else print x is odd. So this is basically our function is now defined. Now we need to call this function. To call this function, we'll call the function. How you can call a function? We'll first we'll write the name of the function, which is even odd. followed by the parenthesis if there is an argument needed. Yes, in this code we need an argument. Let's say if we want to give a number, let's say 4. Also we'll call second time this function just to check that the other parameters, and we give this as the parameter as 3. Okay, so it's saying that 4 is even and 3 is odd, and in this way this code is perfectly fine and it's working rightly. Let's see what is a default argument. In functions, we have a default argument. A default argument is a parameter that assumes a default value if a value is not provided by the user. So we'll learn about here default parameter. Okay, so default parameter is a parameter that assumes a default value if a value is not provided by a user. The user. So let's see a Python program that will demonstrate the working of a default parameter. Let's see. If we have a function, let's say def, we have the function, let's say fun, then we have two arguments, let's say one is x and the other one is y. Let's see, supposedly if we give the value of y here as 50, let's suppose, and we'll print x as x and y as y. Print we go for y. Okay, let's suppose like we do this, then, and if we call this function as fun 10, let's say we have not like in a very correct way we should have given two parameters x and y. So we should give, when we are calling this function, we should give at least two parameters to it. Let's see what does this say. Okay, so since you have not given any value for y, and you have not defined here that 10 should be which, like 10 should be considered as the value of which for which parameter, by default it has been taken that x is now given the value 10 and y has been given the value 50, which is like a default one. Let's see if we remove this y value. Okay, so it will say that missing one required position argument. It will say that since your function should have the your function has two parameters or the two arguments, then when you're calling the function, you should give the two parameters only. Suppose if you write 20 here. Okay, so it will say that x is 20 now and y is, sorry, x is 10 and y is 20. Now we'll see how the keyword parameters work. So keyword arguments are, the basic idea behind the keyword argument is to allow the caller to specify the argument name with values so that the caller does not need to remember the order of parameters. Basically, in the keyword argument, the basic idea behind is that the caller should specify the argument name with values so that the caller does not need to remember the order of the parameters everywhere. Let's say, okay, we'll use a multi-line comment here. Keyword parameter. Okay, so what does a keyword parameter do? It allows the caller to specify the arguments to specify the argument name with values so that the caller does not need to remember the order of parameter, does not need to remember the order of parameters. Okay, this was about the keyword parameter. Let's see an example of a piece of code where we could demonstrate this. Okay, so we'll basically define a function. Let's say we have a function named student, which has got the two parameters. First is first name, and the second parameter is last name. Okay, let's say write print first name print last name. Okay, so this is just the statement of our function. Now we'll call the function. To call the function, we'll write the name of the function, which is student. If we say that the first name is equal to Python and last name works. Okay, then we'll call the function again and we'll write uh, let's say we'll call the last name first. Let's say practice we'll now call this first parameter, that is first name. Okay, so let's see if we run this code. Okay, so here we have created a function named student, which has the two parameters, first name and the last name. If we have a small statement inside a function which says that print the first name and the last name, and now in the main body of the code we call this student function. Here in the first in the above examples what we are taking, we are not specifying the name of the parameter over there. Now here we are specifying the name of the parameter. Like we have two parameters, first name and last name. For the first name we have defined that please give the name as first name as Python and the comma the last name as works. But when we call this student function second time, we define the last name first and the first name after it. But since we have defined the name of the parameter over here, then this order will not matter when we are calling the function. It will be executed and the first name will be given the value as Python only and the last name will be given the value as practice only. Now we'll see the positional arguments. Okay, So we use a positional argument during the function call so that the first argument or value is assigned to name and the second argument or value is assigned to age. Okay, so there's an example here. So if we have a, let's say if we have a function name person, okay, and we have the two parameters inside it, name and age, okay. Now if we print hi my name is, okay, and if we print this name here, okay, and the second one if we print age, okay, my age is, okay. So this was all about the function basically here. Now if we call this function, let's see if we call person and we write, let's say Arun comma 27, okay. Let's see what does this prints. Sorry, it must be in the string, I guess. Yeah. Okay, so it's been printed that my name is Arun and my age is 27. Now, in this second case, if we comment this line, sorry, if we comment this line and we write, we call the function as person 27 comma Arun. Let's see what does this say. Okay, this is again happening. Okay. So this is wrong. This is basically the parameters have been exchanged, which shouldn't be the case. Let's see if we define, okay, now since this is wrong because the parameters have been exchanged, hence the order of the parameters matters. Yes, in this case, if you do it this way, that if you define the name of the parameter and then assign the value to it, it won't matter. The order of that, the order of the parameter won't matter there. Now we'll see some of the anonymous functions in Python. Okay, so in Python, anonymous functions mean that a function is without a name. When a function does not have any name, we call that function as an anonymous function. Or as per our knowledge, we use the def keyword to define a normal function or to create a normal user-defined function. But in case of anonymous functions, we use a keyword lambda. Let's see how you can define a anonymous function in Python. Okay, we'll use a called def. We want to have the cube of any number. Let's say if we have that number as x. Return x into x into x. Okay. Now, if we have a variable named say cube v1, let's say it's a value, it's a variable name here, and if we write lambda x x multiplied x. Okay. So in the first line of code, we have basically defined a function using def keyword. That is just a normal way of defining a function. Whereas we in the second part we have used a lambda keyword to define a function here. Let's say if you print both of this, print, let's say cube 7, and the second one, if we call it the function defined by lambda keyword, we will write cube v1. Okay. 7. Since the cube of a 7 will remain fixed, and I think the cube of 7 is 343. So using the def keyword, it should also return the same value, and using the lambda keyword, it should also return the same value. And hence, we'll see that how it's working. Yeah, similarly, 343 is the cube of 7, and both way we can define function using def keyword also. And if you want to define an anonymous function in Python, you will use a lambda keyword. Let's see how this lambda keyword works. A cube v1 will store the value of the result of the function lambda. Here lambda is a keyword, x is a parameter, and followed by a colon. After the colon, we define the work which actually needs to be done by a parameter to result into a function. Okay, now we'll see a simple example of how we can swap two numbers in Python using function. Let's see, we'll write here function to swap two numbers. Okay, let's see if we have a keyword def. We have a function name as swap. Let's see, we have numbers as x comma y. We have a temporary variable, let's say temp is equal to x. Then x is equal to y. And this y is equal to x, let's say. Okay. Let's say if we have the x value as 1, y value as 3, and we call the function swap x comma y. Okay. And now we'll again print x and we'll print y. Okay. So here we'll also print the value of x and y so that we could see that the changes have been made or not. Print x and print y. Okay. Okay, so the changes have been made. First y is equals to 10. Let's remove this. I think it's not. Okay. Okay. We'll write here only the print statement. Okay, yes. So we define a function using def keyword with the name swap with two parameters x and y. We had a temporary variable named temp here in which we have stored the original value of x. Now once the value takes the value of variable y takes the value of x, the x value will go nowhere, and now this y variable will have a temporary value of x which has stored been earlier. Now when we print this x and y, the reverse values of x and y will be printed. In the main body of the code, we have the value of x as 1, y as 3. When we perform the function swap here with x and y as a parameter, the value of x and y have been interchanged, X which was initially 1 is now 3, Y which was initially 3 is now 1. So this was about the functions in Python. Let's see how we can define a function inside a function. Basically, the function inside a function is known as recursion. Recursion can be the process of defining something in terms of itself. Like if you define a piece of code that is just putting or working on a task that is a task of a parent function, you can define it inside it. And this process is known as recursion. So what are some of the advantages of recursion? Let's see. Okay. Recursion is a process in which a function calls itself directly or indirectly. It could be any of the way. It could be directly as well, or it could be indirectly as well. Okay. Some of the advantages of using recursion are, as told earlier, that when you create a function, it comes with two advantages. One is it increases the code reusability, and other is it increases the code readability. Similarly, in case of recursion, a complicated function can be split into smaller subproblems, utilizing more recursion and making the program or a piece of code more readable. Also, recursive functions, matlab like it makes the code look more simple and effective in the same time. Let's write these advantages of recursion. Number one is it splits down the big problem into smaller subproblems. Okay. Similarly, in case second advantage is it makes the code look simple and effective. But it too comes with the disadvantages. A lot of memory and time is being taken through recursive call, which make it expensive for use. Recursive functions are also very challenging when you are coming up with the debugging. Okay, so some of the disadvantages, yeah, limitations, let's see. It takes lots of memory and time. Since in nowadays a problem of memory is not a basic problem, since there are a lot of devices invented where we could store a large amount of data, but a matter of fact is that it requires a lot of time. And for a good program and for a good problem statement to be valid and effective, it must have a very less time complexity. So if a program is taking a lot of time, means there's a need or there's a scope of some more effective tools which should be taken care in making a code more like less time consuming. It takes lots of memory and time. And is time consuming. Hence it's expensive. It's expensive. Okay. Second is sometimes it's very challenging to debug. The it's challenging to debug the code, because the recursive calls make it difficult to debug the code. Let's see the basic syntax of a recursive function. Okay, if we have a def keyword and we have a function name fun here. Okay, and if you have some piece of code, let's say it's there, and if we call a function inside this only. So this basically is a recursive call here. Now we'll see how we can like use now we'll see some of the basic applications of using a recursive function. First we'll see how we can like have a print a factorial of a number using recursive function. Let's see, we have a def keyword and we have a recurse function for a factorial. As the parameter, let's say n. Okay. So if n is equal to 1, let's say return n. Sorry, return n. Else return n star recurse n minus 1. Okay. Let's see if we have this n is equal to 6. Equal to 6. Now we should have a basic conditions also defined. Let's see if we have a if condition there. If n is less than 0, then for a negative numbers we don't have any factorial defined, na? So we simply print here please enter a positive number. Okay. Okay. Elif if n is equal to 0, if n has the value 0, then please print the factorial of a number is the factorial of a number is 1. Else print factorial of a number is. Now here we'll call the function which is a recurse and we'll give the parameter is n. Okay. Now let's see. Okay. So it's saying the factorial of a number is 720. Okay. Since we know that we have given the number as 6, if now it will go to the if condition, it's not true. Since it's not less than 6, then it will go to the elif part. Since it's not equal to 0, hence it will go to the else part. In else part, there is a function call which is recurse function. It will go to the function, and it will again be passed to a if condition. If the value of n is 1, then please return 1. Since it's not 1, it will go to the else part. Here, this n will return, it will write 6 into recurse factorial 5. This is again the calling of the function recurse factorial. Now this recurse factorial will call 5 into recurse factorial 4. This chain will go on till we have the recurse factorial as 1. As soon as we have this recurse factorial 1, and this if condition will be valid, it will return in 1. Then all of the elements from 1 to 6 will be multiplied and will result in the factorial of a number. Now we'll see another example of how we can print the Fibonacci series up to n terms using the recursive function. Fibonacci series up to n terms. Okay. Let's say we have a def keyword and we have a recurse. Fibonacci. We have, let's say, okay. Okay. If n is less than or equal to 1, we return n. Else return recurse Fibonacci n minus 1. Why n minus 1? Just to, because we know that if one time it has been executed, the terms left will be n minus 1. Let's say if we have the initial value of n as 10. Okay. Now, if this n is less than or equal to 0, we'll simply write print, please enter a positive number. If now elif okay, else if we read the else part, else print Fibonacci series okay. Now here we'll use the for loop to print the each value. Let's say for I in range n, because still only that numbers we want the Fibonacci series, na? Print recurse Fibonacci n. Sorry, I kept. Okay. Since the logic is little wrong here, we have not added the second term. Since you know that Fibonacci series, let me tell you what is actually the Fibonacci series. Yeah. So it starts with the 0, then 1, and then 1, and then 2, then 3, then 5, and then 8, and then 13, and keep on so on. So in basically in this, the first and the second element are always 0 and 1. These 0 and 1 will add to become 1. Now the first and then the last, and the first two elements will again be added. Then 1 and 1 will become 2. 2 plus 1 become 3. 3 plus 2 becomes 5, and this 5 plus 3 becomes 8. 8 plus 5 becomes 13, and this until uh, the up to n terms the series goes on. So here we have forgot to add the second term, that is recurs. Cos Fibonacci n minus 2, since we want to add the second element. Okay. Okay. So the 10 elements or the first 10 elements of Fibonacci series are now printed here. Let's see. What is a tail recursion? A unique type of recursion where the last procedure of a function is recursive call. Okay, so what is a tail recursion? Tail recursion is basically where a function last statement is a recursive call. Okay, that is called the tail recursion. Okay, a type of recursion. A type of recursion in which the last function call is a recursive call. It's a recursive call. Since we saw how we can do the uh, calculate the factorial of a number using recursive function. So this method was actually the way this was a non-tail recursive way. Now we'll use a recursive we'll use the tail recursive function to calculate the factorial of a number. Let's do it. Okay. Let's say if we have a dev keyword here, we have a recurse factorial. We have two parameters, let's say n, and we have a parameter just the value initially 1. Okay. Now if n is equal to 0, return a, else return recur recur facto n minus 1 comma n into a. Now we'll print the result by calling the function. Okay. Print recur facto 6. Okay. This was using the a tail recursive function. I think there's a problem, I guess. What we did in this. Okay, got it. Okay, so this was because there's some problem. So basically, the time is about to end. Okay. So in the recursive function, what we saw basically from functions, we'll see how what all we saw. Okay. So in the we saw what is function. Basically, the function is a block of statement that returns a specific task. Some of the benefits that are associated with the functions are that it increases the code readability and it increases the code reusability. There are two types of functions in Python: built-in functions and the user-defined functions. Built-in functions are the functions that are already defined in the Python libraries and you can use it anywhere in your code. Example, like it has a math.library has a power function, a sine function, a cos function. Similarly, a second type of function is a user-defined function. In a user-defined function, where the user creates its own function based upon the requirement. So to create a function inside a Python, we use a def keyword followed by a name of the function with the parentheses, then a colon and a block of statements. To call a function inside a Python, we use a function name followed by parentheses. These parentheses can have the parameters or cannot have the parameters based upon the names. This is a basic example of how we have like called the function and define a function. This was a program to make you learn about the parameters. If the parameters are required, then you when you call a function, you have to provide that many parameters that you've defined in the initial stage of a function creation. Then we created a function for to say whether a number is a even or not, even or odd. Then we saw a type of parameters. One was default parameter, other was keyword parameter, third was positional parameter. Then we saw how anonymous functions are created in Python. Anonymous functions are functions which do not have name, which are basically created using lambda keyword. Then we saw a function to swap two numbers inside Python. Then we saw how function calls itself, which is basically a recursion. So some of the advantages of recursion is that it splits down the bigger problem into smaller subproblems. It makes the code looks simple and effective. Some of the limitations that come up with the recursion is that it takes up a lot of memory and is time consuming. Hence, it's sometimes expensive as well. Another limitation of the recursion was that it is challenging to debug the code since there are a lot of function calls. Hence, it becomes a problem to find out where the program actually got the issue. The syntax for the recursive function is that you call a function inside a function. Then we got a function to find a factorial of a number. Then we got a for recursive function to print a Fibonacci series up to n terms. So this was all about today. Tomorrow we will meet up to discuss about the other fundamental concepts of Python. Till today, we have actually done with the most of the part of the Python. Just like we got to know about the variables, we got to know about the list, tuples, loops, conditional statements, dictionary, sets, functions, recursion. Tomorrow we'll learn about the file handling and the classes and objects. This was all about today. Keep keep a good health, and we'll meet soon tomorrow.